Welcome. Today our group is proud to be presenting the control system for BatBot 5, our Sonar device. My name is Nathan Cox, and I'm the lead for the electronics and software development for this robot. BatBot 5 is an experimental, cutting-edge biomimetic sonar device. It uses two movable ears and a movable nose leaf to modulate sound, enhancing its sensing capabilities. This device has been developed under sponsorship of the Naval Engineering Education Consortium in collaboration with the Center for Bio-Inspired Science and Technology at Virginia Tech. Our goal is to eventually be able to incorporate this system onto small vehicles such as unmanned underwater vehicles and multi-rotor aircraft. The control system that our team has developed enables a high-performance product, mainly because of these 5 features: low latency, onboard processing power, user-friendly interface, a small form factor, and a high-quality audio recording. These features are key to the effective functioning of the BatBot as an easy-to-use sonar device that collects accurate data. BatBot 5 has a low latency control system that allows for seamless data recording and actuation. The Teensy 4.0 microcontrollers seen here are synchronized with the Adafruit M4 microcontroller so that the data acquisition and soft robotic ear and nose leaf actuation can be performed simultaneously. The Teensy board operates at an impressive 400 MHz clock rate and ensures a precise and rapid actuation cycle with no latency so that not a single echo is missed by the movement of the ears. As a standalone system, the BatBot is also capable of performing advanced onboard signal processing. BatBot 5 is the first version of the system to contain a computer, and processing power was a key concern. As such, the NVIDIA Jetson Nano was selected. With this computer, deep learning tasks can be accelerated using a 128 CUDA core GPU. In addition, standard filtering and data collection tasks can be performed with little impact on performance due to its quad-core CPU. From a user perspective, the availability of a Linux OS also makes this system easy to work with for any developers or customers. User interaction with the Sonar device during routine operation has been made as simple as possible using a top-mounted HD touchscreen loaded with a control and data display graphic user interface. No external devices are required to operate BatBot 5, making it a truly standalone system. With the possibility that our device will one day be mounted onto a vehicle, the touchscreen has been made removable for easy integration with the vehicle. Additionally, given that our aim is to provide a compact device, BatBot 5 has a custom and highly integrated electrical system that aims to minimize the number of cables and space occupied by power electronics. To this end, our team has developed over 5 custom PCBs that interface with each other using standardized connectors. For power distribution, our power is initially supplied through the lithium polymer battery. That voltage is then converted using a custom set of power cards that can be swapped out to provide a user-defined number of 3.3 volt, 5 volt, or 12 volt rails. This eliminates the need for external power supplies. All of this work has been performed to make the system light enough to be mounted as a payload onto a multi-rotor drone. More importantly, our sonar system's design is focused on audio quality as a top priority. The speaker system on BatBot 5 is a plasma emitter that operates using a 7 kilovolt arc, creating a point source of up to 110 decibels in volume at our target ultrasonic range. For audio recording, the Adafruit Grand Central's analog to digital converters are used. They are capable of recording 12-bit audio at 500 kilosamples per second, providing a Nyquist frequency of 250 kilohertz. This is more than sufficient for our purposes. To maximize the sensitivity of BatBot 5's recording equipment, custom microphones were developed. These microphones have peak sensitivity in the same ultrasonic range as our emitter, guaranteeing that we can extract the maximum amount of data from collected echoes. BatBot 5 is currently in the testing phase with the electronics and software operational on a test bench. Integration is currently underway. Although the electronics used for the BatBot may not be the most cutting edge in the world, they work together to provide a more than adequate capability to this highly advanced sonar system. When completed, BatBot 5 will be used by graduate students to collect valuable data and build onboard deep learning tools so that the BatBot can begin to complete complex tasks such as foliage gap detection, environmental mapping, and directional object detection and classification. And with that, all that's left to say is thank you for attending, and please reach out with any questions you might have about this system.